guys, how's it going? Welcome to class. Good morning. Good morning. How was your evening? Okay, good. Um, all right. So hey, we're gonna do something a little different today. Instead of like doing notes, we're just gonna dive right into the homework assignment together. Okay. So you guys get out a piece of paper and turn to page 120. And I think if we just work through some problems together, we'll just kind of like learn by doing a little bit, because there's not really anything new in the rest of the section notes. Okay. Okay. All right. So number 11. A particle starts by moving to the right along the horizontal line. The graph of its position function is shown. When is the particle moving to the right, moving to the left, standing still? No, it's not. I know, that's why we're doing this together.
Oh, it's moving to the left between 2 and 3.
There you go.
And it's standing still between 1 and 2 and 4 and going to
Okay,
the right.
and so the connection that we're supposed to be making here is, like I said, this is a physics problem. What is the definition of velocity? Absolute value. No, speed is the absolute value. Velocity is what's the definition? Change in distance divided by change in time. Okay? Good. Velocity is the change in distance divided by the change in time. The distance is my y, right? The time is my x's. And so really what this is it's just the slope of the position time curve. Okay? So the particle is moving to the right when the velocity is what? When the velocity is positive. It's going to the left when the velocity is negative, and standing still when the velocity is 0. So when the slope of this graph is positive, so the particle is moving to the right. When the slope of this graph is negative, the particle is moving to the left. Yeah? Okay? So, when is it moving to the right? Which is where? 0 to 1. And 4 to 6. Okay? When is it moving to the left? 2 to 3. And when is it standing still? Perfecto. Alright, B, draw the graph of the velocity function. You're welcome, Cindy. Okay, so now let's draw the graph of the velocity. So what is the velocity when it's moving to the right from 0 to 1? 3. Okay, so that means, this is weird, but that means that, let's see, 1, 2, 3, 4, 5, 6. Oh, goodness. Nope, never going to happen. The velocity from 0 to 1 is 3. So at 3, I'm just going to pull a whole segment. Okay. What is the velocity from 2 to 3? Oh, from 1 to 2. Sorry. Yeah, so we did 0 to 1. From 1 to 2, it's 0. So that means you would have a little. What's the velocity from 2 to 3? It's left, but what is it? What's the numerical value? Negative. Be more specific. 2. So that means from 2 to 3, I need to have a little horizontal line segment from there. Okay. How about 3 to 4? 0. So put a little thing right there. Okay. And then 4 to 6 is all one chunk, so we can skip. So just put that together. What is the velocity from time t equals 4 to t equals 6? Is it 1? That means you get a negative 1. Okay? So yes, this is a step one. Because velocity doesn't change like that, right? It has to slow down and all that kind of stuff. But they're just trying to get you to see the change because the slope of the graph and what time is it, Mackenzie? It's what? Okay, how about number 12? Same kind of idea. But this is in the context of a race. Okay? So we still have a position time function. Describe and compare how the runners run the race. What? Okay, so runner B, Cameron says, gets faster. Okay? Because what Cameron is recognizing is that the slope of this curve is going to be their velocity. So the slope here is relatively flat, and then it gets steeper and steeper and steeper as they continue to run. What's going on with runner? Start off pretty slow. What's going on with runner A? Steady pace. Runner B is, or running A is running at a steady pace. Okay, because it's a linear thing. Okay, at what time is the distance between the runners the greatest?
Right in that middle where
Where do you think that? Give me an estimate.
like the end value?
Yeah.
9.
9. So this is 10, so we'll try 9, okay.
Might be like 9.5.
If I look, I'm sure I can do that if I keep the graph. Yes. Yes. And then it's getting smaller there. Okay, we'll take it. Yep, 9. 9? 9.
No, we're not doing the thing.
Okay, so at t equals 9 seconds, the distance between those two graphs is the largest. At what time do they have the same velocity? 0? Because they're standing still. Okay. No. Danger, danger, danger. Not understanding. When the tangent lines are the same. Right. When the tangent lines would be the same, yeah. Because when do they have the same velocity? So the velocity is the slope of this line, yes? Okay, so that means velocity is the same the whole time. Where will this one have that velocity? Not there, not there, not, weird, right at about 9. And, I guess you could technically say t equals 0 because it's just starting and you could, just label that. But definitely not at 14. That's what I was concerned with. Because that's when they're the same position. Okay, so their velocity should also be the same at the same place where their distance is farthest. Okay? Alright. Okay, number 13. If a ball is thrown into the air with a velocity of 40 feet per second, its height in feet after 2 seconds is given by y equals 40t minus 16t squared. Find the velocity, the instantaneous velocity when t equals 2. No, what would you get if you put 2 in for t? What would you get if you put 2 in for t? No, what would you get if you put 2 in for t? No, what would you get if you put 2 in for t? Not what answer, what would it represent? Right, the distance, yes, the distance, its location, its height above the ground, okay? Because this is distance versus time, okay? You could, if it was a month ago, but what we're going to do now is we're going to find the limit. Yeah, no, right. That's absolutely right. But instead of doing it that way and putting in numbers closer and closer to 2, what we're going to do is we're going to find the limit as h approaches 0 of f of 2 plus h minus f of 2 divided by h.
So we did have to put 2 in there.
Eventually. All right. So what is f of 2 plus h?
40 or 80.
So I have to distribute the 40, so it's going to be 80 plus 40h minus, I'll do this in 2 steps, 16 times, what's 2 plus 8 squared?
4 plus 4, 8 plus 8 squared.
Okay, and we'll mess with that in a second. Minus f of 2, what's f of 2? That was 16. 2 plus 2, isn't it? 80 minus 64, 16.
Woo!
All over h. Okay, so this is the limit as h approaches 0 of 80 plus 48. Now I'm going to distribute this negative 16. And that's going to give me negative 64 minus 54h minus 16h squared minus 16 all over h. Yeah, and actually 80 minus 64 minus 16 equals 0. So that's a happy day.
We have 40 minus 64.
40h minus 64h is negative 24h. Minus 16h squared. All over h. Factor out h. Did you say it already? Okay, so the h's cancel, and then that allows us to plug in 0 directly, and we get an answer of negative 24. And that would be feet per second. Maybe I'm lying.
Why is, okay,
Maybe I just looked it up before you did that.
what does the negative mean?
What does the negative mean? Great question.
Then we just write that down.
Okay, number 14. Number 14, same deal as the last one. If a rock is thrown upward on the planet Mars with a velocity 10 meters per second, blah, 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 blah. I don't know. Find the velocity of the rock after 1 second. So, same dealio. What am I going to do to solve this problem? What am I going to do to solve this problem? I'm going to plug in 1 second. No, I'm not going to do that anymore. Yeah, I'm going to do the h. So I'm going to go the limit as h approaches 0. Okay. What do I plug in for t? If I want to know the velocity after 1 second. 1 plus 8. So I'm going to do, this is 8. So I'm going to do h of 1 plus h minus h of 1 over 8. So I'm going to take and plug 1 plus h into the h function. So I have to distribute the 10.
See, it already happened.
10 plus 10t.
You can do 10 plus 10 H.
I am confusing myself. Minus 1.86 times 1 plus 8 squared, which will be
1 plus 3H plus 8 squared.
okay. Minus, what do you get when you plug in 1? 10 minus 1.86, which is 8.14. Yeah, I was going to say, I'm slowly do the next step. Alright, so that's the limit as h approaches 0 of, I have to distribute that negative 1.86. So 10 plus 10h minus 1.86 minus what? 2 times 1.86. Okay, what? 2 times 1.86. Minus 1.86 h squared minus 8.14 all over h. Okay? So, guess what happens now? I'm canceling. The 10s cancel with the negative 1.86 and the negative 8.14. Yeah, if it doesn't, then you did something wrong. Okay? Then I'm going to ignore Jake. I'm not going to factor out an h because I don't want to rewrite that step. I'm just going to cancel this h, this h, one of those h's, and one of those h's. Okay? Okay, yes. And then that's actually my answer is 10 minus 3.72 because this has an h in it still. So when I plug in 0 for h, that whole term is going to go away. So 10 minus 3.72 gives us 6.28. Nope, that's the correct answer. Okay, now it says find the velocity of the rock when t equals a. So that is going to be super fun because now instead of plugging in 1 plus h, what are we going to plug in? What are we going to plug in this time? What are we going to plug in this time?
Instead of 1, you put A.
You put in a, so we're going to plug a plus h into. So my original function was f of t equals 10t minus, what was it? 1.86 t squared. So now I'm going to do the same thing, but I'm going to do the limit as h approaches 0 of f of a plus h minus f of a over h. Okay? And when I do this, now you're going to get a really good insight into what the actual answer is. Okay? Because when we come up with the functions for our answers, the numerical values are hard to figure out how they came up with. But you should be able to see how this question and the answer we're going to get relate to each other. Okay? So again, I plug in a plus h, so I distribute the 10. So I go 10a plus 10h minus 1.86 times a plus h squared, which is a squared plus 2ah plus h squared, minus this time f of a, so that's 10a minus 1.86 times a squared all over h. That's that fun first step. And you get to do some good old algebra. Okay, what do I do next? Can I distribute first? Okay. So 10a plus 10h minus 1.86a squared minus, what did we decide that was? 3.72a minus 1.86a squared minus 10a plus 1.86a all over H. That's so hard. The 10A cancels with the 10A. And that was Cameron, yep, good one. The negative 1.86a squared and the positive 1.86a squared also cancel. Okay? And so now every term that I have left has an h in it, which is what I wanted. So instead of rewriting this with the h factored out, hopefully you're big enough, old enough, you've seen this enough times to say I'm going to cancel an h in every term. Like that. Okay? And then you plug in 0 for h. Well, this doesn't have an h in it, so it stays as 10. This doesn't have an h in it, so it stays as negative 3.72a. And then this does have an h in it, so it comes out to be 0. So my answer is 10 minus 3.72a. I don't know, did you? Okay, C, when will the rock hit the surface? How do you figure out when it will hit the surface? Good, when y equals 0, so I'm going to take this bad boy right here and set it equal to 0. And so I'll do that by factoring out a c. Yeah! So one of the answers obviously is c equals 0. The other answer is if I take 10 minus 1.86c and set it equal to 0, that means I have to subtract 10 from both sides, divide by 1.86. I don't want to do that in my head. Then 5.38. Okay.
That's when you first let it go.
Yep, so when you throw it and then when it comes back down. Alright, and then last one, with what velocity will the rock hit the surface? So previously, what we would have had to do is do this whole process again with 5.38 as our A. But now that we have a formula, all I have to do, this is my velocity. Okay, so all I have to do is just plug in 5.38 for A. So 10 minus 3.72 times 5.38. Anybody got that? Negative 10.0136. Okay, so it'll hit the ground on Mars with the velocity of negative 10.01 feet per second. And negative is a good thing there because it's coming down. Also, you should notice that you threw it upwards with the velocity of 10 meters per second, and it's landing with the velocity of 10 meters per second, which is the way we're taught in the United States. It's going to be the same way we use it really fast. Okay? Alright, does that help to kind of go through something? Okay, so we have like a half an hour left in class, I know, but I'm just going to go ahead and give you an assignment to work on, and give you some time to work so that you can check for you to have this. Say the word. Say the word cheater? That's a negative word.
Or we forgot to go up.
Forgetful.
She's got to forgive us. Can we just do it on the paper? This is your 26.
That's enough? Oh, 9 problems. You feel like that's a lot of problems?
It took us almost a whole series.
No, it didn't. It just took like 10 minutes.
These are all the quick ones we go.
The word